Good afternoon, everyone, and welcome back to the second session, post-lunch. And we have three speakers. The first is Dr. Souvik Roy from the Economic Research Unit in Indian Statistical Institute, Kolkata. And he's going to talk on a unified characterization of randomized strategy proof rules. You have 20 minutes.
Hi. Firstly, thank you very much, Somdatta and all other organizers, Anirvanda, for inviting me, for giving me this opportunity to present my work. So I'm a bit confused about what to present here. Can you please make it louder? Because as I see, you are, and myself, we are from diverse backgrounds. And if I present some very advanced results, just to introduce the notations and the terminologies, perhaps I will consume most of my time. So instead, what I'm planning is to present the basic model of mechanism design so that you get to know something about mechanism design. And then I will give you some overview of my results. So I at least want to ensure that you know the basic idea of mechanism design. So my paper is actually not in mechanism design. It's a special case of mechanism design, which is called social choice theory. As the name suggests, I have to make a choice for a society. So let us consider an example. Suppose you people here, you constitute a society, and I have to make a choice for all of you. Suppose we have to go for a conference dinner tonight, and there are three kind of menus, South Indian, North Indian, and East Indian. And I have to decide one of that. How can I do that? Very simple way to do this is to ask you people that what you want. But of course, some people would like to have South Indian, some others would like to have North Indian, and so on. And then I'm confused. I don't know which one to finally decide. You may say that if there is a majority, most people, if they want some particular thing, say South Indian, then I can just decide the South Indian menu for the dinner, conference dinner. Okay, that's just one way to resolve this problem, but it can be resolved in many other ways. More importantly, the very simple rule, the majority rule, of course there are problems with majority rule because there might be ties, it might not be defined and so on. But more than that, this majority rule has real problems, game theoretically. That is something I would like to explain you first. So roughly the problem is this, that I have to make a choice for a society. And now for this example, you are the people in the society. Each of you has a preference over the outcomes. Here there are three outcomes, South Indian, North Indian, and East Indian. And based on your preferences, I am the organizer for the time being. I'm from somebody from the conference organizing committee, and I have to select one menu, one item for you. And I have some concerns. The first one is very simple. Suppose you all want one particular dish, say South Indian. Then I want to make sure that I would select South Indian dish for today's dinner. That's a very obvious thing. If you all want, there is no point in deciding something else. After all, I want to serve you. The other concern is a bit, is game theoretic, is a bit tricky, I would say. I want you to not manipulate my rule. So what is manipulation? Let us first understand. Forget about this example. First, simply a manipulation is something where you lie about your type, where you lie about what you want, and you get something better. Simple example is that, suppose I am at home and I am fighting with my brother for the TV channel that I would like to watch. My brother says that he wants to watch some sports channel. I say, I am a little kid, I want to watch some cartoon channel. Then my mother comes, then okay, she asks my brother and myself both that which one you want. My brother says that, okay, I want to watch the sports channel, but I'm kind of fine with the cartoon channel. And I say, no, I will die if I will not eat, I will not do this thing, that thing, if you don't let me watch the cartoon channel. Actually, that is not true. It's just I am kind of putting pressure on my mother, just overemphasizing my preference, so that I get what I want. And this is very common in real life. So you manipulate by what you want by overly, by focusing overly or by giving overly emphasis on what you want. So in this case, such a thing can happen. For instance, just assume that here, for just to be real, there are most people who are Bengalis. And say, there's a majority, say out of, we are 50 people here, 20 people are Bengalis and 20 others are South Indians. So if you're from North India, then you know you don't get a chance to get this North Indian dish anyway. So you don't fight for it. So you suppose, because you are North Indian, your true preference is that firstly you want to have North Indian dish, then South Indian perhaps, and then East Indian. But you realize that just by saying that I want North Indian as my first choice is going to do nothing. It doesn't help you, because anyway there are not many people in favor of North Indian. So what you do, instead of saying this, you say, no, my first preference is, so what did I say about the preference? North Indian, then South Indian, then East Indian, say. Then you say that, no, my first preference is South Indian, and then I don't like at all the Bengali foods. My first preference is South Indian. So you slightly misrepresent your preference just by swapping North Indian and South Indian at the top two position. So practically what you are doing, you are putting, because you know the North Indian is not anyway going to win, you are putting some more focus on the South Indian, and so that the organizer, who is anyway cannot decide the North Indian food, now is more in favor of South Indian. By doing this, maybe now the organizer, because so many people, North Indian people, they are saying, so there are 10 North Indian people, all of them are saying that no, we want South Indian, the organizer now decides the South Indian food. But you see, in reality, these people, though they prefer South Indian to East Indian food, they do not really prefer South Indian food to the extent they say. And maybe you decided the South Indian food because you felt that it is the best of so many people. So I will explain it in more details, but this is a manipulation where you misrepresent your preference, you lie to the designer, and you get something better according to your true preference. And we want to have a rule, a decision rule. So what is a decision rule? You tell me your preferences and I decide something for you. So that's a decision rule. I want to have a decision rule that is not manipulable. And as Shaprabhu actually yesterday kind of gave an overview of all these results, for a voting scenario means suppose there are three parties, left, center, and the right, and you want to elect one of those parties and you are the voters. No matter what rule I use, other than the dictatorial rule, I will explain the dictatorial rule shortly, it is an extreme rule. No matter what rule I use, it will be either not unanimous or not strategic group. Or it will be manipulable. Roughly speaking, summarizing, though manipulability and unanimity, so unanimity you remember, yeah? Unanimity says that if you all want one particular thing, that is decided. Of course, it's a very desirable condition. Non-manipulability is also a desirable condition. If you do experiments, and you will see that there are dishonest people who can do some extra work, who can kind of back calculate the outcome and do manipulation. So as a designer, I want to protect the society from dishonest people. So I want to ensure that my rule is not manipulable. And then I end up with a very, very undesirable, unacceptable rule called the dictatorial rule. Dictatorial rule works in the following manner. In this whole society, I select my favorite person, and I say, no matter what other people want, whatever you want will be the final decision. It's absolutely not acceptable rule. So you realize one very simple thing, that you want a rule which is unanimous, which is not manipulable, and of course not dictatorial. And then you don't have anything. So you have nothing. So this is a very, it's a very, what I should say, very important result in social choice theory. And how do you, which says that politics has to be corrupted, roughly speaking. You cannot, of course, unanimity cannot be dispensed with. Unanimity is very important. And then every rule, non-dictatorial, and you also cannot have a dictatorial rule in any democracy. Then every rule, if you want to ensure non-dictatorship, if you want to ensure unanimity, then every rule is manipulable. That means dishonest people will be able to be better off by lying or by doing some strict strategic corruption and so on. Now, how do you, so that is a summary of what is there in the social choice theory. It's long back. Now, how do you resolve this situation? How do you evade this impossibility situation? Actually, you cannot do anything about it, except in some situations, maybe as the designer, I have some more information about your preference. You see, your power of manipulation depends on to what extent you can lie. Suppose I have some information about you. Suppose I know that if you are from North India, your top preference has to be North Indian. Then I won't allow you to say that, no, I want South Indian food, that's my first preference. I won't allow you to say, because I have that information. Of course, in this case, I cannot say that if somebody is from North India, his top preference has to be North Indian food. But there can be situations, I will give you examples, where the designer might have some additional information about the preferences of the individuals, which in turn means that if you try to manipulate or if you try to lie, then maybe the designer will catch you. I mean, designer will find it out. Okay. So now what is, I must give you an example where this happens. One very important example or very well-studied example in game theory or mechanism design is the set of single picket preferences or single picket domain. So what is single picket? Suppose the alternatives, the choices, the outcomes, like these three parties or South Indian, North Indian, East Indian. So these are something I call alternatives. Suppose you can order them in some way such that the preferences will have satisfied some structure with respect to the ordering. Just think of the situation where the political parties are either left or central or right. So there are three political parties, one is left, one is central, and one is right. I'm not saying it is necessarily true, but it is possible that whenever the top preference of a person is left, so whenever you are a left guy, you will prefer the central party to the extreme right party. And similarly, whenever your preference is right, you are an extreme right person, then you will prefer the central, say, Congress party to the extreme left party. So this is like a natural thing. Consider the situation, and also Saprabha also gave this example. Think of the temperature of this room. I have to decide the temperature based on your preferences. You all say, somebody says, I want 22 degrees, somebody says 27 degrees, and something. And based on all this, I have to decide the temperature. But here also I know that if your favorite temperature is, say, 25 degrees Celsius, then you must prefer 26 degrees Celsius to 27 degrees, and 27 degrees to 28 degrees, and so on. So there are situations where the designer, just by using his or her common sense, can predict or can ensure some part of the preference, not completely, but he can say that preferences must satisfy some structure. And in return, this kind of minimizes, or not I should say minimizes, it kind of restricts your freedom to lie. Because now consider this temperature setting problem. If you just to lie, if you say my favorite temperature is 22 degrees Celsius, if you don't give me that, then I want 28 degrees Celsius, and then I want 23 degrees Celsius. If you cannot say something random. I say you are a crazy guy, you get out of this room. So now, but in the case of foods, North Indian, South Indian, and East Indian, practically you can say anything. I cannot just strongly claim that you are lying. So there are situations where the preferences have some structure, and because the preferences have some structures, the agents, the voters, they don't have enough freedom to lie, and the designer can exploit or can use that restriction to design maybe, possibly, some better rules. Better rules means some rule that is unanimous, strategy-proof, as well as not dictatorial. And my work is, you see, as the title says, that a unified characterization of randomized strategy-proof rules. My work is a bit, is an advanced version of this rule. Let me just give you the motivation of this. Consider the situation, very extreme situation that, and again I have to decide the food perhaps. Suppose you are 50, 25 people want, preference of 25 of you is North Indian, then South Indian, then East Indian. And for the rest 25, it's exactly the opposite. East Indian, then North Indian, then South Indian. As a designer, what I should do? I see that people are exactly divided and they are exactly opposite to each other, and each part, each cluster, they are of equal size. Of course, the natural solution is to, for me, or you may think it what you will do, for me, the natural situation is to toss a coin. Here there are three things, so I cannot toss a coin, just to draw one number randomly from three numbers, and based on that, I will decide. So I just say that, you see, you are all tired. You are completely diversified. Neither of these items have any weightage from you. So what I do, from some bottle or something, there will be three pages with written North Indian, South Indian, blah, 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 and then I pick one randomly. Whatever is chosen is the outcome. what is the advantage of this? Of course, finally the outcome will be either in favor of one side or on the other side. The advantage is that now you cannot very easily accuse me of partiality. If you have to select something deterministically, no matter what I do, you will say, okay, you are favoring somebody or somebody else. Here I say that the outcome was decided by a random experiment and everything was given equal chance. So that's why whatever problem I have explained right now can be in another way resolved by allowing for random rules. So my work is on that. And strategy prudence, because you see now, in the previous case, only one item was decided for the whole society. But now, a probability distribution of that. So what is an outcome in the random scenario? I say, I, for instance, consider this rule. I say for each item, I will see how many people want that at their first position, and I will assign that probability, that proportion of probability to that item. For instance, if you're 50 people here, and 20 people want North Indian, and 20 people want South Indian, and 10 people want East Indian, then I give 0.4 probability to North Indian, 0.4 probability to South Indian, and 0.2 probability to East Indian. And I do a random experiment according to that, and I decide the outcome. So here, the added advantage is that, firstly, of course, it resolves some of the issues of being partial and so on. But the problem is that, now, what is the notion of manipulability here? Because you see, at the end, whatever I am deciding is just a random outcome. You do not know the outcome. I say, if your preferences are like this, then this probability distribution will be chosen, or the outcome will be decided following this probability distribution. So now you need some way to compare these random outcomes. But there is a standard way called stochastic dominance that it's a very natural way that resolves this, that answers this, or that gives a way to compare. Roughly speaking, it assumes that people are very greedy, they're crazy. So they prefer one probability distribution to other if there is, it will be a very vague way to explain this, if there is some possibility, according to which they will get a better outcome. But what is meant by some possibility? It is, just take it verbally. It is not possible to explain this thing. So here in my paper, what I do, I characterize all these randomized rules on a class of domains that particularly include the single picket domains, unrestricted domain, that includes a big class of domains. So I give a structure of these rules. And the structure of these rules is, of course, as you can sense, that it will be a bit technical, and it is somewhat technical. I do not want to explain the technicalities. But roughly speaking, the rules are kind of monotone. I'm just giving you some vague idea of these rules, and then I will stop. So firstly, you remember that I am working in a scenario where the alternatives can be arranged. They can be ordered. Say left, center, and right. So the alternatives, there is something left, there is right, which are the extreme position, and there is something in the center. So they are ordered. And then these rules are kind of saying that if your preference, so first of all, these rules, there's an important property these rules have, that is called tops onlyness. It only depends on your top preference. So beyond the top preference, what you want, I do not care. Whenever I am deciding, I say, okay, what is your preference? You say, okay, left, and then I will go, okay, stop. I don't need to know anything more. Just based on your top preference, I will decide the rule. So these rules have this property. And additionally, how these rules work is it looks at the top-ranked alternatives, top-ranked choices of the people, and somehow it decides the outcome with respect to which, so for every outcome, because you have an ordering, for every outcome, you can see how many people are on the right of the outcome and how many people are on the left of the outcome. How many people, by how many people, I mean that for how many people the top ranked alternative is on the right of the outcome and on the left of the outcome. Suppose the alternatives are A1, A2 up to A10 instead of left, center, and right. Then for A5, for instance, I'm just checking with A5, then I can see how many people are there whose top ranked alternative is either A5 or A6 or so on, say 7, 8. And for how many people it's either A4 or 3 and so on. And then I do some kind of balance. I select the outcome, A5 or A6, with respect to which the two sides are in a sense balanced. And what is meant by balance is, again, it's not possible without going too details, but in some sense balanced. So I can intuitively, you can say that I select the outcome as A7 if there are kind of equal number of people on the right of A7 and on the left of A7. I can do these things because, as I've told, the alternatives are ordered. These are kind of nice rules. Another way to explain the deterministic version, because here I am saying is I am working with random rules. The deterministic version of these rules is very simple. Let me explain at least that. So I look at your top ranked alternative. I order them from the lowest to the highest. So suppose the alternatives are A1 to A10, and there are 4 people, and their tops are A2, then A5, then A6, and then A9. So I order them A2, A5, A6, and A9. Then out of these four people, I add 3 more alternatives just randomly out of my own choice. Because you are 4 people, I add 3. So 1 less than the number of voters, just out of my choice. And of course, how I should make this choice, that depends on what I want. Maybe some extreme choice, but whatever. I add 3 more. Say I add A1, A2, and A10. So I have now 7 alternatives, A1, A2, A3, which I have added, and also 4 of your top-ranked alternatives. So I forgot that A3, A4, A6, and A9, whatever. Then out of these 7 alternatives, I select the median. You know the median? Median of a set of numbers is that if you order them from the lowest to the highest or largest, then it's the middlemost, the one which appears at the middlemost position. For instance, if you have 3 numbers, A1, A3, A9, then the median is A3. And so on. If you have 4 numbers, then the median is not unique. The median. So if you have 4 numbers, A1, A3, A4, and A9, then the median can be either A3 or A4. Depending on, sometimes people take it as the average. So these median rules, they satisfy these properties. They are not dictatorial. They are unanimous and strategy proof on single picket domains. Of course, they do not work on the unrestricted domain. And some version of those, random version of those rules work as the random rule on this very general class of domains. So yeah, I want to keep it at a very basic level. So I don't want to go through, you may, if you want, I don't know how to go. So you see, there are very heavy definitions, and I don't want to go through those things. It won't make any sense here. Huh? Okay, forget that. I have stopped at the most messy definition. I should not stop here. If I have some thank, then I should stop there. But I'm sorry, I have just the summary. Anyway.
So thank you, Souvik. Do you have questions, anyone? If not, we'll continue in the discussion session if you have something to discuss. Thank you very much.